Hello everyone, this is Mr. Cunningham, and today we're going to be talking about how to draw Lewis structures with something called polyatomic ions. Now don't be intimidated by that name, we'll talk about them more a little bit later. But we've been learning how to draw Lewis structures with molecules. But before that, we talked about drawing electron dot structures for things called ions. And polyatomic ions are kind of like a combination of ions and molecules. That's because polyatomic ions are pretty much just charged molecules. So what we're going to do right now is we're going to kind of break down what polyatomic ions means to make it a little less intimidating. So let's break down the words polyatomic ion. So poly is a word meaning more than one. Atomic means atom, and ion means charged particle. So a polyatomic ion is really just a molecule containing more than one atom that happens to be charged. So let's look at one, and let's look at how we can draw the Lewis structure for it. So here's a polyatomic ion that's called hydroxide, and its molecular formula is OH-. So normally it would have 7 valence electrons, because oxygen is bringing 6 and hydrogen is bringing 1. However, you have to notice this little negative sign. That means we have an extra electron. So instead of having 7 valence electrons, we actually are having 8. So now we need to find our octet electrons. So oxygen is wanting to have 8 electrons, and hydrogen wants to have 2. So our octet electron number is 10. Now we need to find our bonding electrons, and we do that by taking our octet electrons and subtracting our valence electrons. So that's 10 minus 8, which gives us 2 bonding electrons. And we put that bond in between the O and the H. Now we need to remember, we need to find our non-bonding electrons. And non-bonding electrons, we take our valence electrons and subtract our bonding electrons. So that's 8 minus 2, which gives us 6 non-bonding electrons. And we put those around the oxygen. Now, something that you might notice is that oxygen, when we have done Lewis structures in the past, wants to make 2 bonds. But when we do polyatomic ions, those rules have to be bent a little bit. So instead of oxygen only wanting to form 2 bonds, when we do Lewis structures with polyatomic ions, oxygen will actually sometimes form 1, 2, or 3 bonds. So you have to keep that in mind. Also, we need to do something else to this molecule. And that's because, remember when we started, hydroxide has a negative overall charge. So we need to show that somehow. And we can show that by putting brackets around it in a negative charge. That shows us that this entire molecule is negatively charged. So now, let's move on to another one. This is called ammonium, and this one has a positive charge. So, normally we would have 9 valence electrons, and that's because nitrogen brings 5 electrons, and hydrogen brings 4. The 4 hydrogens bring 4 electrons. So the normal valence electrons would be 9. But we have to notice the charge. It's a plus sign, which means we have a loss of an electron. So our valence electron number is actually 8. So our valence electron number is 8. Now we need to find our octet electrons. So nitrogen wants to have 8 electrons, and each hydrogen wants to have 2. But we had 4 hydrogens. So all of the hydrogens together would want to have 8 electrons, and then the nitrogen would want to have 8 electrons. So that means our octet electron number is 16. Now we need to find our bonding electrons. So our OE minus our VE is actually 8. So that gives us 8 bonding electrons. So we can draw those in around our nitrogen. Now something that you might notice is that nitrogen, when we've done our Lewis structures before, wants to form 3 bonds. But here it's actually doing 4. So this is similar to what we just said with oxygen. Nitrogen, even though it normally wants to have 3 bonds, now because it's a polyatomic ion, we have to bend those rules. So in polyatomic ions, nitrogen will form 2, 3, and sometimes 4 bonds. So we have to keep that in mind. Also, now we need to find the non-bonding electrons. And to do non-bonding electrons, we have to do valence electrons minus bonding electrons. But we have 8 valence electrons, and we've already used 8 in our bonds. So that means we don't have any more non-bonding, we don't have any non-bonding electrons. So right now, we're almost done. Remember when we did hydroxide, we had to put brackets around it. So we have to do the same thing with NH4+, except this time we have to put a plus sign to show that this entire molecule is positively charged. Coco wanted to remind you that cations are positive, just like the ammonium ion that we just did. So she wanted to remind you of that. So that's going to finish up our lecture over drawing Lewis structures with polyatomic ions. So if you have any questions, please make sure you write them down so we can talk about them in class. Thank you for listening, and enjoy the rest of your night.